Hello, this is Dr. Dan Burleson, and this is a quick lecture on basic data types, importing, and basic displays within MATLAB. Today we're going to be working in the command window that you see here. We're also going to be taking note of the current folder and the workspace, the current folder located on your left, the workspace located on your right. Before you start, you should make sure that you have downloaded all the data files that we'll be working with, including pick1, PV cell, record1, X values, and Y values. There is a worksheet associated with this lecture called Basic Data Types, so you're encouraged to follow along, writing out notes as we do things in the command window. So we're going to start by defining some basic data types and some basic variables. So for instance, if we want to define a variable A, we can say that A is equal to five. If I hit enter, I now will notice that in my workspace, I have a variable that is defined as a value of 5, and that value, A is equal to 5, has been repeated on my command window. I can define another variable B as equal to 10. If I don't want it to repeat on my command window or output on my command window, I can suppress that command, meaning that it will still execute. I'll still define my variable B is equal to 10, but it will not output to the command window. I suppress by using a semicolon. But if I use a semicolon, the line executes. B is now saved as a value of 10. It just doesn't repeat on my command window. So I can evaluate both of these variables by double-clicking on them, and in the variable window will pop up. That will show a 1-by-1 double. So one variable, one value, that is 5. I can now do math associated with these variables. So I can say A plus B is equal to C. If you try to execute this line, you're going to notice that there's an error. In MATLAB, whatever variable is not defined yet needs to be on the left side, and anything on the right side of your equal sign needs to have been defined. So since A and B are defined, they need to be on the right, and C needs to be on the left. So the correct way of writing this line is actually C is equal to A plus B. MATLAB was trying to help us out by saying B is equal to C. Even that's not exactly what we want. So I'm going to suppress that line, hit enter. That's going to execute my line. I now have a variable C that's 10 plus 5, which is 15, and that is now stored in my workspace. I can do multiplication and division as well, so I can define a variable D is equal to A times B, and I can have E is equal to A divided by B. So a couple things to note here is that spacing doesn't matter. You'll see the difference between my line D and line C, that spacing between my operators, it still executes. I do have to be cautious about this line here. So this red text indicates an error, undefined function or variable B. Capital B is not defined. A lowercase b is, it's equal to 10, but capital B is not. MATLAB is case sensitive in most cases. Throughout the videos, you'll see cases where it may or may not matter, but in terms of variable naming, it is important. And so if you see something where you know you have defined a variable, but MATLAB is telling you it's undefined, it may just simply be a capitalization error, like you see here. In this case, MATLAB is helping us out, and it is correct. It's got actually A divided by B. I can suppress that line, press enter, and now I have E is equal to 10 to 5 divided by 10, which is 0.5. I can also define vectors and matrices, and where there's going to be a lot of videos and practice with these, but just so that we're understanding the different data types MATLAB has, I can define a vector F is equal to, and when I define vectors, I use a bracket. I say 10, comma 20, or space 20, space 30. In this case, spacing does matter. This indicates a new value. So 10 and a space, 20 and a space, and 30 indicates 3 different values. I'm not going to suppress it so you can see what it looks like here. F is equal to a vector that's 10, 20, and 30. And in my workspace, I see it as a 1 by 3, 1 row, 3 column vector. F is 10, 20, 30. A really good way to visualize it is by double-clicking on your variable, and in the variable window, you see 10, 20, 30, very similar to a view you would see in Excel that you might be familiar with. Similarly, I can define f as equal to 10, 20, 30. In this case, you'll notice that the result is the exact same. So commas and spaces when defining vectors both separate out our values. So either one is fine. If I want to create a matrix, so I want to have multiple rows and multiple columns of values, I can use a semicolon to go to the next row. So I can say I is equal to 1, 3, and then I want to go to the next row. So I use a semicolon, 4, 5. I'm going to not suppress it so that we see what it looks like here in the command window, 1, 3, 4, 5. And then if I open it up in my variable window, I see 1, 3, 4, 5. You'll notice that the semicolon, when it's inside a bracket, now helps us define a matrix. When it's outside and at the end of an executed line, it suppresses. So where you put your semicolon matters, how you use it does matter. So I can do the same line. If you hit the up button, it will look back at previous lines that you've executed in your command window. So I can go up and hit right. So that's going to bring back this line. I can put a semicolon here outside my bracket. The only thing that's going to change about my line of code is that it now suppresses. The actual execution of the line is the same. So I can define other types of matrices. So I can define something that has 3 rows and 2 columns. So for example, J, I can say, and I'm going to use a bracket, 4 space 5, comma 6 space 7, or semicolon 8 space 9. I've now created something that has 3 rows and 2 columns across. For me, I really like seeing my matrices and vectors in variable view. It's all broken up into cells. I understand kind of what the rows are, what the columns are. Especially early on, this is a good way to double check that you're visualizing in your head what actually those variables mean. We can also define ranges of vectors and ranges of matrices with increments that are the same. So for example, I can create a vector G that starts at 10, goes by 10, and goes to 50. So again, we're going to touch base on all this stuff when we talk about vectors and matrices, but for G, I can now create a vector that starts at 10, ends at 50 by increments of 10, so it goes 10, 20, 30, 40, 50. Especially when we're developing very long vector values that we're going to use to do calculations with, we don't want to have to type those out by hand. You notice the middle value represents the increment. If I leave that blank, so I say like h is equal to 10 colon 20, 10 is my endpoint, 20 is my starting point, and the increment by default in MATLAB is 1. So 10, 11, 12, and so on. It looks kind of funky here, especially when your vectors start getting very long. That's columns 1 through 7 and 8 through 11. Again, the best way to really double check what you're looking at is going to your workspace, double clicking on the variable and seeing, okay, I have a row vector that starts at 10 and goes all the way to 20. So I would not rely on the command window or not suppressing output in order to view your variables. I would really use the variable window in your workspace as a tool to understand what's going on. We can also define strings, and we can do that by saying, well, K is equal to Dr. B. And I use the quotation to define my string. It turns purple, so that indicates a closed string. If I press enter, I now have a string K that is equal to Dr. Burleson or Dr. B. I can create a string array. So just like I was able to create a variable that had multiple numerical values, I can create a vector of string values. So I can say, let's say KK is equal to Dr. B. And let's include the other first-year faculty, Dr. M, Dr. K, and Dr. Z. We'll cheat and have Dr. M count for 2 of our faculty members. If I suppress this, nothing will output, but I can go and look into my workspace and see that KK is a 1x4 string array. And if I double click, I have all these values, 1, 2, 3, 4 values, all saved as strings. So just like we can with numerical values, we can do the same with strings. These are really useful when we have names associated with each column of our data or each row. Maybe they represent the days of the week or a station ID or a material or something like that. We can use that in this case. We can also define cell arrays. So if I have a variable t, I can say that's equal to Dr. We'll use Dr. Z as an example. A single quote is going to provide a different data type than a double quotation. So you need to be cautious of that punctuation. In this case, it's a character. So with a character, it's a 1x5 character, meaning each of these points in here represent a character. D, R, period, and Z. Now you might be thinking that's only 4. So what we're missing is that space in between. The space counts as a character. So 1 is the D, 2 is the R, 3 is the period, 4 is the space, and 5 is the Z. If you add extra spaces at the end, it will count that as a character. So this is a 1x5 character. We can use what we call a cell array to store values that are both numerical and strings. So if I have, let's say, CA is equal to, and I use the curly brackets, I can create a vector 5 to 10 stored in one spot, and I can put my KK, which is my string array of first-year faculty, in the other. I'm going to not suppress this. So this ends up being a 1x2 cell array. We use curly brackets to define cell arrays. The value of cell arrays is purely that we can store vectors, matrices, string arrays, single numerical values, single character strings, all in one. So in this case, I have a 1x6 double, which is these 5, 6, 7, 8, 9, 10, and I have a 1x4 string. I can update this as well, and I can treat it just like a matrix. So I can go to the next row, and maybe I want to add my T, which is the character string, and maybe I just want to add a single value 6. So now I have 4 values, a 2x2 cell array that includes a vector, a string array, a character string, and a single numerical value. Again, the value of a cell array is that, and you may come across this when you're downloading data, is that it stores both string and text values and kind of puts it all into one package for you. You have to pull all these different packages out to use them. Well, we won't use cell arrays too much in this class. We'll mostly focus on string arrays, vectors, matrices, and numerical values. But it's a good thing to know as you download different types of data. So now I want to get into some importing of data and just some basic display. So this is where you will definitely need to have these variables here. We haven't talked about this yet because we've been using the command window and just defining variables. But when we import data into MATLAB, it needs to be showing in our current folder. When we import data from the command window and from our script, it can only access what's in our current folder. The way you access your current folders, you hit this down arrow, and you can navigate to wherever you've saved these values or these data types. So if you have a 1331 folder, or what I would do is create a specific folder for this lecture. So for me, it's data types lecture. I would have them all in there. So, and then find that folder, press open, and they should all display here. So before we start, if this isn't showing up, make sure to hit the down green arrow in your current folder and make sure to download all of these files off of Blackboard and follow along. So it's really important to note how we load in this different data and the commands that we use. You're going to be dealing with different data types in this class. It's an important aspect of this class. And you may end up referring back to this worksheet or these notes to remember how you load in this data. For a text file, we're going to start with the xvalues.txt. We're going to use the load command. So load xvalues. .txt. I want to point out a few things. When we use a single quote, so we create a character array, we create our character as our variable name. It needs to match perfectly with what we see here. You need to include the extension, and we use the load command for text. If I use load, it's going to load in a value, a variable. It automatically names that variable x values. So it names it the same as your variable name. Sometimes that's fine, other times that's not okay. So you'll notice that it's now a 1x5 vector with different values there. The preference is to define the variable that you're using. That way, no matter what the name, if the name of the variable or the file changes, your variable stays the same. If I wanted to assign a variable name to these values, I could say instead, data1, we'll call it data1, is equal to, and then I have my load command. Load is a function. When I open my parentheses, it's asking for information. This is a function, and inside my parentheses, it's asking for information. In this case, it's asking for the file name. We're not going to worry too much about these other options at this time. So it needs a file name. I'm going to do xvalues.txt. I press enter. Because I've defined it as a variable, it's going to show up in my command window. And because I've defined it as data1, I should now in my workspace have a data1 variable that's a 1x15. So a couple things to note is that anytime you bring in data and with it as a text, you should use the load command. Remember the extension. You want to define a variable name, and that way you're using that same variable name throughout, and that way if the file name changes, the variable doesn't. Otherwise, if the file name changes, then you have to change everything down below in your code. The other thing is that you want to suppress this because you don't want all of this junk to show up on the command window. So if I hit the up button and go back, I really want my line to look something like that. So now let's look at the XLS value. So we have our X values, let's bring in our Y values. The command that I'm going to use to bring in an XLS data set is called XLS read. So XLS read, I open my parentheses, it's asking again for my file name. I'm going to provide some extra documentation on Blackboard and may have a further discussion on loading the Excel files, but for now, we're just going to worry about bringing in this one file. So at Y values.xls, the extension does matter. Again, if I press enter, it's going to, for XLS read, it doesn't automatically save the variable as Y values like it did for load. It just creates a generic answers. Generic answer is a really bad way of storing your data because that can be very easily overwritten. So again, just like we defined data1 equal to load, that's how we want to bring in our Excel file. So anytime we're bringing in an Excel file, we want to say data and choose a variable name. So I'll call it data2 is equal to XLS read. And I'm going to do Y values.xls. And I want to suppress that so that this stuff doesn't show up. Press enter. I now have a data2 that is showing up. It is also a 1x15. If I want to see what it looks like, I can double click and look at my 1x15 vector, and it's not showing up on my command window. Let's look at some more values. So we have a .csv data type. In order to load in a .csv data type, we're going to use the CSV read command. So CSV read, there is no text read. There's load for text, XLS read for Excel files, and CSV read. Do not make this mistake of using XLS read on a CSV file. Yes, Microsoft Excel is equipped to open up a CSV file in Excel by default, but it doesn't mean you can use the CSV read command or the XLS read command to load in a CSV file. You need to use a CSV read. So let's bring in the CSV file. It's going to be pvcells.csv. Again, just like XLS read, it does the same thing. It defines a default value answers. You'll notice that it overwrote the previous answers. That's the problem, which is having a generic answers. And it also outputted it to the command window. So what we want to do is define this as data3 is equal to CSV read. Here are the different options that go inside our function. We just want the file name, which is pvcell.csv. Suppress, and now we have a data3. So we're building in our data sets. I now want to load in my last Excel. So we've already done Excel, so I'll do that quickly. Data4, I want to bring in as XLS read, and that's going to be record1.xls. The last data type we have here is pic1.jpg. This is an image. We know it can be a PNG file, it can be a JPEG, JPEG file. If it is an image file, you need to use something called IMRead. CSV read for CSV files, XLS read for XL files, load for text files, and IMRead for image files. So for pic1, you're gonna say IMRead. Let's call it picture as the variable. So it's gonna be IMRead pic1. Again, you have to include the extension because we can use different extensions in this. If you press enter, if you forget to put suppress, image files are loaded with data, and this is gonna start happening. If this happens, just calmly click on your command window and do Control-C. That works for Macs or PCs. If you hit Control-C, it will stop the program. You have to click on the command window first. If that happens, it's okay. We now have a lot of junk on our command window. But what we want to do is hit the up button, go back to our previous command, and make sure to suppress. So make sure to, anytime you bring in an image, make sure to suppress that command, otherwise you're going to get a lot of junk out there, and it will definitely slow down the processing. So we have our different variables here. Let's go ahead and show some basic ways to display and export those values. So there's a command called plot that can create plots with XY values. They need to be the same length. So we have a 1x15 and a 1x15. So we have two data types that have 15 values. Let's plot that. So I can say plot, use the plot command. It asks for an X and Y value. Well, I have a variable for my X. It's going to be data1, comma, and then I have a variable for my Y. That's going to be data2. There's other options. There's going to be other videos on plotting to kind of see some of the nuances with that. But for now, just basic plotting, and we have this plot here. It looks kind of messy, so we're going to learn later how to mess around with it, but that's how we do our basic plot. The key is to make sure that these two variables are the same length. We can do 3D plots, so we can look at surface or how things might look like on the surface. I can simply just put in my Z value, so I could put in data3. If I do surf data3, it's going to create kind of a surface. So if you have elevation data, if you have elevation data, you can do that as well. So all of these different variable types should be showing up on your window. If they're not showing up on mine, on the video, you should be getting a surface. And let me, just to make sure that they're showing up, let me change my view. So here's our surf figure, in case it wasn't showing up before. I'm going to go hit the up button twice, go back to my plot so you can see the plot. Each time we create a new figure, it overwrites the previous, so we still only have figure 1. We can image our picture. So if I want to show my picture as an image, I can use the image command and say image picture. Again, since I did all caps for picture here, I need all caps for my variable. I do that, say hello to Leo and Wyatt, who will end up making cameos on quite a bit of our videos, especially once we get to imaging. This is how we output our image, is using the image command. imread brings it in, image pops it out. And lastly, we can also output values as sound. And so that data, you'll notice this data4 value is a vector that has 2 columns. These columns are, in order to produce sound, we need a 2-column vector, but we can use the command sound. And I can say data4.
Welcome to 1331.
And you should have been able to hear the sound related to data4. So those are some basic ways to display our data or to show it, whether it's audio, visual, different methods. The data type and what we're trying to show does matter in terms of the commands that we use. We also a lot of times want to export our data. And so if we're trying to export our data, we can export our data using commands just like we have CSV write, we have CSV read, we have a command called CSV write. So if I wanted to take my data set, so I can take, maybe I want to output one of the variables that I had previously made. So let's take my H value here. I want to output my H value, so I can use CSV write. For CSV write, it wants a file name, so I can say maybe final H dot CSV. And then it wants the variable that's going to be outputted as that file name. I'm going to choose H. So for CSV write, I choose the file name first and then the variable that's going into that file name. If I press enter, on the left-hand side in my current folder, that is where my exported file will go. So if you're exporting results, just like if you're importing results, it needs to be in the current folder. If you're exporting results, those exported results are going to show in the current folder. We can also write out an image, so I can use imwrite. Imwrite is flipped. I don't know why they flipped it, but they did. So in this case, we want the variable which is picture, and I want to output the file name, and I might call this Wyatt and Leo.jpg, or maybe let's just do it. Let's save it as a PNG file. So I can even use MATLAB to convert my image files. You'll notice I don't need to suppress these because it's just exporting. I should have now a PNG file called Wyatt and Leo that shows up in my current folder. The last way we can export results is through the save command. The save command is nice because it allows us to output things as multiple variables. So we can output a file name that maybe is like we call all variables. And I'm going to save this as a .mat file, and we're going to. And now I can have multiple variables that go into there. So I can put B into there, I can put C, I can put D, I could put KK, and maybe if I want to put my picture. If I try to do this, what save is having a problem in here. It must be a string scalar or a character vector. So let's look into our function and see what it's really asking for. So it's asking for our file name. We'll give it a file name called test. In this case, you don't want to give it a extension. It will automatically add the .mat. And let's just try one variable and build up. So if you're getting this error as a repeat, one of the things I wanted to show you in this is that you have the ability to use the help menu. If you click here on save, it's going to bring up it should bring up the help menu for save. And it will give you hints on how to use this file correctly. So I'll give you examples of that. You'll notice that what it's saying is that it must be a string, a scalar, or character vector. And when I look at the examples here, the difference between what I'm doing here and what's here is that my variables are just typed into there, which is fine when I'm doing IM write and CSV write, but for save, they're character strings. So we need to define our variables as character strings. So I'm going to go back to 2 lines ago and turn each of these variable names into character strings. Unlike the previous ones where we can just put the variable name into it as an input, for save, if we're saving a .mat file, we need to use character strings for our variable names. We press enter. We now have a variable .mat file. So I want to close by us bringing this back in and understanding how we load in a .mat file. If I want to start from scratch, I want to kind of clear everything off. If I want to clear my workspace, I'm going to use this clear all command. If I hit clear all, you'll notice my workspace on the right disappears. That is going to erase any memory of any variables that I had. If I now want to clean off my command window, kind of like a dry erase marker, I can do CLC, and that clears that off. So the nice thing about the .mat file is it holds a bunch of variables into there, and it will automatically load those variables in with those names. So if I do the load command and I do all variables .mat, I now have B, C, D, K, K, and picture all saved here. So a .mat file, if given that, is going to have a bunch of variables in here. What you want to do is the first time you get a .mat file is to do load in the mat and figure out what those variable names are. That's what you need to use in your code. You can always assume that the variable names within a .mat file won't change. If you're not sure, you can, since you're in the command window, you can always double click and hit all variables.mat, and it will execute that load and bring it in. So the one thing that's on the sheet to make a note of is loading in a .mat file. We export it using the save command, and we load it in using the load command. So that concludes our discussion of data types, importing, basic displays, and exporting. We're now going to use this data to problem solve in MATLAB.